A street light is at the top of a 10-foot pole. So let's go and write 10 here. A woman is 5.25 feet tall and is walking toward the pole at a speed of 7 feet per second along a straight path. So let's go ahead and say, let's call this distance from the lamp x. And then we're gonna x, and then the distance is the speed at which she's walking toward the lamp is dx over dt is equal to 7 feet per second. And we're gonna make this negative because as every second passes, she's actually getting closer to the lamp, and that means x is decreasing. Right, he's walking toward the pole. And then how fast is the shadow lengthening when she is 50 feet away from the base of the pole? So when x equals to 50, how fast is the shadow? Let's say this is the shadow here. We'll call that length s for shadow. And we're looking for ds over dt. And then we got to figure out how fast that is changing at x equals to 5. Okay. So for these problems, you always need the idea is two triangles, a small triangle and a large triangle. Some constant values. We know the lamp post is 10 feet and she's 5.25 feet. We're going to call this x and s. So we have a small triangle and a large triangle, right? So that distance of the large triangle side in relationship to the small side s is going to be x plus s. So we write a ratio as s over 5.25. That's for our small triangle. And our big triangle is x plus s over 10. Okay. If we take a look at this, if I take the derivative of x, you get dx over dt, and if you take the derivative of s, you get the s over t dt. So we want those two things. Let's go ahead and distribute. We're going to cross multiply our x's and our 5.25 across, so we don't have any fractions. 10s equals to 5.25x plus 5.25s. We'll move the s's to the same side. Let's move that over there. So it's 4.75s is equal to 5.25x. Let's go and just take our derivative. It's 4.75 ds over dt equals to 5.25 dx over dt. We are looking for ds over dt. We have dx over dt, so let's go ahead and rewrite the equation. Whereas ds over dt is equal to 5.25. We're going to divide our 4.75 over from the other side. And our dx over dt is going to be, we said, negative 7 feet per second. Okay. So that's our answer over here for how fast the shadow is moving. How fast is the tip of the shadow moving when she is 50 feet away from the base of the pole? So to figure out how fast the tip of the shadow is moving, we're going to combine both the dx over dt and the ds over dt. So this is going to be negative 7 plus our answer over here, which is also negative 5.25 over 4.75 times a negative 7. And that's a combination of both the woman walking toward the lamp as well as her shadow shrinking. And that is how fast the tip of her shadow is moving.